First of all, my name is Mieke. I work for Sustainable Taranaki, as do some other people here on the talk tonight as well. We are a non-profit organization. We've been around for 33 years, and we really focus on education and support for businesses, communities, schools, whoever wants our support to be more sustainable, think about conservation, waste management, and other sustainable practices in their business, home, school, sports, wherever. So our vision is to hand over a vibrant future to a vibrant, healthy, strong community and environment to the future generations. And we do that with lots of different types of projects, from zero waste, composting workshops, business support. We do nature cleanups. We go into schools. We do tours through recycling facilities. Lots and lots of different things to just also empower people with knowledge and understanding, so it's easier to have behavior change if they understand why they're doing certain things. So the Green Loop came about. One of the projects we did about 2 years ago was called Sustainable Business Support. We went into businesses and would help them look at their sustainable practices and see how we could assist them. And a part of that was doing a waste audit. So we would ask a business to keep 3 to 5 days worth of waste. We would go in and then by hand go through all of it and see exactly what was in their waste bin that would normally go to landfill. As you can expect, we all know that most of that was organic material. About half of all the audits still come back. Some actually are sitting 80%, others at 40%, but on average, half of the bins were still organic material. So that's a bit of a problem. So we would do education on composting. We would help them implement composting on site, or worm farms, bokashi systems. But we realized that the post-consumption foods, the processed food, the raw chickens, the meat, the bones, the cheeses, all of that could not really go into these bins because they would just attract mice and rats and all the cats from the neighborhoods. Now, a big issue in Taranaki is that we do not have an organic waste facility here. So all organic waste is taken out of province, about 300 kilometers north, where it's either composted or goes in a landfill or it's turned into biogas, actually. Even if a business separates the organic waste, it still ends up going into a truck for 300 kilometers, and then the truck comes back 300 kilometers empty. So the carbon footprint is humongous. Plus, we're losing all the nutrients that are still present in the material. So that is a big loss, especially since we are a very dairy kind of a region. Our lands have been, for decades, fertilized with synthetics, and soils are very depleted. So we have a big need for these nutrients to go back into our soil. So that's a big problem. So it kind of stuck with us for a while, like, what can we do with that? And then we did some research online, and we came across Betsy and David doing their city to farm. So we were very interested and did some more research. And so from that, Green Loop is very, very much based on the principles of city to farm. So we treat food waste as a resource. We are trying to make as small as possible circular loop. We also try and stimulate people if they just want to do a little bit of bokashi at home and take into a community garden. That circle is even smaller, so we support that as well. So yeah, like I said, the inspiration was also, so for me, it was just researching, and then David and Betsy, they came to the permaculture hui in Taranaki and did a presentation there. After that, I went to the Hibiscus Coast, and I was lucky enough that I could join them with some farm visits and to really pick the brain and see what they're doing and how they're doing it. So we came back with lots and lots of ideas and started a Green Loop. So this information on this slide is more, sometimes you go into a business and they want to be part of the Green Loop because they just want to do better.
I just wanted to
they have looked into splitting their organic waste and have come to realize that it's 600 kilometers of carbon footprint, and it's not staying in the province, and it's actually a big problem. So they want to do better, and we do not have to convince them. We also come to businesses sometimes that just want support with their overall kind of sustainable management. And these are just some of the things that we would pitch to them, why it is important to be part of Green Loop or any kind of organization that would take their organic material and compost it. So yeah, not only are we keeping all the nutrients here and we're reducing the carbon footprint, but also a lot of people are more aware and that businesses are producing a lot of waste and some are taking responsibilities and others are not. So we find a lot of customers are finding those cafes that do takeaway keep cup, only keep cups, no takeaway cups, will give you a discount. They are part of circular economy. They will only buy seasonal food. They will only buy from locals as much as possible. So with Green Loop, we're trying to show the public and the businesses that by using Green Loop, you can close that circle and we can get some sort of a certification going as well. So people will recognize the brand and the logo as a business that takes responsibility for their impact on the environment. I'll flick through this a bit quick. So how we engage with the businesses, sometimes we don't really need to do much. They already dividing their waste as much as possible. They just want a solution for their post-consumption waste or organic waste. But some of the businesses we work with, and for instance, if you go to a pub with lots of deep fried food and leftover from plate, they would like to know what can we do better. And we go in, we do a waste audit, we make a full report showing them exactly what they can do better, recycling wise, diverting wise, reusing, adjusting portion sizes, all of those kind of things. And of course, Green Loop would be part of that as well. So the audit we do twice a year, once when it's their busy time and once when it's more like a downtime. So we get data that is a little bit more honest over the year. So the problem we're solving, which you always be familiar with, us fellow composters. So the commercial food at the moment travels 300 kilometers out of region. This is the food waste that is being kept separate. If it's not being kept separate, it goes into the landfill, which also travels 200 kilometers south towards Martin, because Taranaki also doesn't have an active landfill. Our landfill was filled by 2019. So for the past almost 7 years, we are now trucking all our waste out of province and making it someone else's problem. So yeah, pretty bad. So we are attacking the problem of the commercial waste traveling a lot. We're also keeping now those nutrients in province. And we are using what comes out of it, the other end, to re-inoculate our depleted dairy soils or get a compost that not only is full of nutrients, but also has the right microbes living in it for a proper nutrient cycle. So it's a local food waste collection, which means that not only is the circle quite small, but we also provide jobs for people local. And in the end, what we're hoping to do, at the moment, the compost that we produce stays on the farm as a sort of a payment for the farmer. In future, we would like to either sell that or use it to support community gardens. It also means that if this beautiful compost goes into our local soils, it means we're getting more nutrient-dense crops. We get healthier animals because they are grazing from healthier soils as well. So yeah, we're keeping the resources in region, and it goes into the loop, back on the plate, and then it comes back through a green loop into the soil. So we're using the bokashi system, very much like CD2 farm. So fermenting using the effective microorganisms. We, at the moment, we are using zinc. So we purchase zinc from the South Islands, which is the inoculant. We provide that to all our businesses that are part of Green Loop, and we give them education. So we go in and we do an educational session with the team that is going to be working with the waste and with the bins, so they understand what bokashi, what it means, how big the layer should be, what can go in and what should not go in, and the reasons why. Because again, we are trying to change behavior, and we believe that when people understand and know why they're doing things the way we ask them to do it, it becomes easier to stick to the rules if you understand why that is. So we're processing all the food that normally, well, it would break down in compost, but as you know, it is tricky. It would attract mice and rats and flies and whatnot. So we are using that specific type of food for the composting. It's an anaerobic process, which means the bins are closed. There's no smells coming off it. Well, there is when you open the bin to add to it. And we're using the EMs, which are safe to use. They're food safe, so there's not an issue to have them sitting near a kitchen or near where you're producing food, because they're absolutely safe to use. So then we asked the people to collect all the offcuts and the food leftovers, what comes off the plates, and what might have been, gone wrong, might have been burnt or too long in the oven. We asked them to keep it during the day in a separate container, but it's smaller, so we have lots of surface so the microbes can get in quick enough. And then only once a day or at the end of the shift, add it to the green loop bin and add the zinc to it. So we don't want them to constantly open and close the bins. So we just ask them to do it once a day if possible. At the moment, we're using 20-liter buckets and 120-liter wheelie bins, depending on the amount they produce. Also, because we don't only work with cafes and restaurants, we also have distilleries, breweries, big hotels, corporate businesses, and we also go to events or weddings. Whoever wants to, try it, we are happy to provide bins. So depending on the volume, we can either provide the buckets or the wheelie bins. We would then pick it up either weekly or fortnightly. And if a bin fills up quicker than expected, we can pick up in between as well. So they get the bin provided, which just like City to Farm has mulch and biochar in the bottom, because obviously this bin is not like a classic bokashi where you have the two containers in each other, so the liquid will be sitting in the bottom. The mulch help with soaking that up, and we also have the biochar in, like Betsy and David do, so we can, as we are making the compost, we are also helping towards sequestering the carbon in the soil. We provide also the zinc, which is in the cost, and whenever the zinc is almost finished, they just put the bucket on the wheelie bin and we'll top it up when we pick up, because our driver has got zinc on board. Once the pickup is finished, our driver will then take it to Nadia's place, which is only 17 kilometers out of town and not 300. Nadia's kindly provided space for us to put the bins. They will then sit there for at least 2 to 3 weeks, depending on the season and temperature. So all the material inside can completely ferment, so the process goes through the whole bin and not just what has been in there longest. Then we will turn the bins after 3 to 4 weeks. We will make compost, clean the bins, and they then go back into circulation to the businesses. We're tracking volumes for reporting. And we're doing lots of other tests as well, which I will hand over to Nadia in a second. So we're also using different methods. We were very keen on initially using the Johnson Su static pile for different reasons. One of them, as we're working with farmers who are really, they have a lot of work, they don't have a lot of time. We wanted to use the system that they don't have to turn. That's much easier for them. We also, as we are a non-profit organization, but as we are very focused on the environment, we'd like to use as many resources that are unwanted as possible. So we're using the outside of an IBC tank, so just the cage itself. We're using discarded drain pipes to make the air vent from. We use all kinds of different shade cloth or windbreak and bird netting. And we're trying all of that to see which one works best. All of these are considered a waste, so sometimes we just about have to sew bits and pieces together. But yeah, as much as we can, we like to use materials that otherwise would go into landfill. We've also started to build, as you can see in the left corner in the bottom, you can see that we have some bays that are built from pellet wood. Another beautiful resource that, pellets are just discarded real easy, and nowadays you can find them everywhere along the roadside. So we are very picky with the pellets, and we've just built some bays as well, the cubic meters, so they get to a decent volume for heat. They'll go for a few rounds, and then we'll just replace them with new pellets. And in the left corner, you can see a cylinder. We also work with some of the cylinders. We've got 3 going at the moment, based on Elaine Ingham's soil food web, a little bit adjusted, sometimes because we like to experiment a lot. So the one that is in this picture here has got one big pipe in the middle. Just like with Johnson Su, there's holes every 15 centimeters on all 4 sides of the pipe. Now it starts getting interesting, guys, because from here, very quickly, I'm going to hand over to Nadia, because in Taranaki, there is a funding, which is a collaboration between Massey University and the Bedford Nichols Trust. They support research specifically for innovative projects that will support the agriculture or horticulture industry. So with Green Loop, we applied for the trust last year and we won the Pivot Awards. this money cannot be used to pay people or anything. This is very specific money that will have to go towards testing, science, data collection of what we are doing. So that was really exciting because we applied initially for NFV funding, and it looked really, really promising. But in the end, we did not get that funding because we were too small in the amount of money we wanted, and also in volumes, apparently. So that was a bit of that was very disappointing. But in the meantime, we'd had so much co-funding secured that we could start Green Loop anyway. But it wasn't as much as we had hoped. So the whole testing the soil and the science kind of, yeah, we kind of had to skip that. But with this funding being available for us, we could now work together with Massey University and do lots of really interesting research. So a little bit here about what we're doing. So Fuller Lights, which is Nadja's business. She is Elaine Ingham, soil food web trained scientist. So she is looking specifically at the microbial communities. We also have testing in nanopore sequencing and eDNA. I am very keen to hand over to Nadja now because she is much better in explaining all this and she's very knowledgeable. So Nadja, if you just want to say when I should swap to the next slide, I'll just hush for a moment and just go through the motions with you. Thank you.
All right, thanks, Mieke. It's so strange to hear you calling me by my first name because everybody else knows me by Caroline. So I know that's been an adjustment for you. But good evening, everyone. And thank you so much to the network for hosting events like this where we can all learn from each other, and also to Sustainable Taranaki who are leading the way here locally to really make a difference in a sustainable front for us. And for me, being a doctor and also being quite a big nerd and always loving microbiology when I was studying medicine, to be able to sort of shift a bit and do soil health has been quite a wonderful and exciting a part of my future career. So yeah, it's been great to be able to sort of be part of this, and to be awarded this award was really great because now we could together with Massey really look at get to the specifics, like actually knowing what the functional guilds are of what are breaking down the compost during the different phases when you're making hot compost in particular. And when you have different systems, if you're using anaerobic with anaerobic into aerobic, and whether you turn or not. So there's been quite a lot of interest as well from Massey, which has been wonderful. So we're working together with Professor Peter Lockhart and Dragana, who are, and Trish, who are doing the nanopore sequencing, and then it's tying together with the soil food web. So the soil food web is slightly different because normally you are looking at the compost once it's almost matured to actually see that you have full functional guilds, whereas we're kind of looking at it through the stages with the nanopore technology, so we can actually understand the organisms as they bust and boom and how they mature over time. So I'll get you to swap this slide, Mieke. Thank you.
Oh, yeah.
So all
just
good,
some
all
action
good.
pictures in here.
Yeah, so this is our sort of first testing. So one of those things is how we could do a sort of a composite soil core, almost like an ice core, to actually see through the different layers what the organisms were, to get a set of samples that then can be kind of tested with the nanopore technology over time to see how that works. We're doing some of them which are turned and some of them which are static. And I know, Betsy, I think your piles are kind of static. So it'll be really interesting to see if there's a difference when it comes to the end of X time, to see when things are mature, if the biology is the same across the unturned versus the turned, just with time. So that's a really, it'll be lovely to sort of answer that question to ensure that we get rid of all the potential pathogens, because not all the heat is distributed evenly when you layer up the food and the carbon layers with the wood chip versus mixing it when it's all together as a more homogeneous mix. So you can do the next slide, please, Mieke. So this is just some photographs that I've been taking under the microscope, and this is just one particular pile. Next slide. And so just having a look at as Mieke mentioned, within the bins there is wood chip and then a bokashi, as in a bokashi system with the biochar. So on the bottom there's little black things. I'm not quite sure if you can see my mouse if I hover over it, but the bottom left-hand picture is the biochar. And then the zing is what's at 100x. So that's the background picture there. So you can see those big yeasts everywhere, which and some lactic acid bacteria in there as well. At this point, when we're doing the soil food web work, you're just actually looking for good and bad organisms, or not necessarily bad, or aerobic and anaerobic organisms and potential pathogens. So obviously within this there's nothing, but you don't actually really say it's this specific organism with this genus, this lactobacillus bacteria, or this specific strain of fungal spore. So you don't do that, and I was always kind of curious about that because I think that infers a lot. So next slide, please. And so this is just a picture of this post-consumption food waste. So if I were to look at this under the microscope, I have not put any images in here because it's basically a bit of a mess, right? So, but next slide, please. When we start to just collecting the juice at the bottom of the bins, because as you tip the bins over, often there's that sort of like percolate that comes through. So this is just a quick look at that, and I haven't put any videos in here, so they're just static shots. So I'm sorry about that, because when you see them live and moving under the microscope, that can be very exciting, as Astrid will, I'm sure, tell us as well. And so you can see there's quite a lot of facultative anaerobes here. So there's lots of lactic acid, lactobacillus in here, and actinomycetes, as well as some yeast, and then just some organic matter globules around, plus some diplococci as well, and diplobacillus. So next slide, please. And then, so we're actively monitoring every day, and then doing within 9 different measurements per IBC Johnson Sioux unit, and then just looking at when it's turned or what's happening within the environment has been quite interesting. Yes, the rats do seem to enjoy it because it does have a particular, obviously it's fresh food, well, not so fresh anymore, but definitely is attracting. But as well as so looking at the different types of maggots that are coming in and the different types of beetles that are all part of those shredders and decomposers, when it looks at the macroscopic organisms that are responsible for breaking down material into compost versus the microscopic ones. So yeah, lots of active monitoring. And I know people have said, when I've asked in the past, how hot does everything get? They were like, hot. And I was like, yeah, hot. So we've had our highest temperature sitting at 184 degrees Fahrenheit. And I use the Fahrenheit just because on this thermometer, it's a little bit more accurate than adding into the Celsius, but you can see underneath, so you can get it into sort of 1 or 2 increments, so it's a little bit easier to sort of look at, but that does confuse everyone because we obviously work in Celsius and not in Fahrenheit. So yeah, 80 degrees, I have been a bit worried that things would start to burn, but no, they haven't. And just been checking the temps through the vents as well, because they definitely help to sort of or release the heat, and also bring in the air and suck in the air, which is really important. And you can see the moisture condensation in the vents as well. And we're getting to the point now where we're getting some mushrooms growing on the top with some time. So that's really exciting as well, as things are starting to sort of cool off if they've met their heating cycles. So, so lots of active monitoring throughout this process. Next slide, please. And so just talking about fungi, so yes, there's all of these lovely shaggy end caps that are coming through, and I hadn't ever seen one of these before, and I was like, oh, that looks like vomit, and yes, it's a dog vomit fungus. So I was very happy to see that. I was gleefully enjoyed, and then it sort of came and went sort of really, really quickly. So if you're not looking at it every day, they can come and go quite rapidly. That pile through the wood chip layer has really decomposed because of this fungus in there in particular. And just in the center, there's this last pile that we turned. The third turn had a whole lot of fungal hyphae and mushrooms actually growing right in the center of it towards the bottom, which was I've never seen before. So that was quite surprising. Um, Next slide, please. And that's just a picture of having, removing the vents. And this is a mixed system, so a turn system. So you can see it's quite moist. You can see the white on the, just by the removed component. That's a lot of anaerobic components there. So actinomycetes is often facultatively anaerobic. So it often has that sort of whitish kind of, almost like a hyphae appearance, but it's not. Next slide, please. And then these are just some snapshots. So nice, that big brown blob. I'll go clockwise. So nice, a bit of cellulose there, and then you could see some protozoal cysts involved. Here are some spores, which are fungal spores, and a fungal spore over here that's starting to sort of grow a little. This component in here has got some fungal hyphae. And you can see again the actinomycetes in the back there. There are some curved guys in here as well, so we just got to check to see what's happening within that space. But I was thrilled to see some bacterial feeding nematodes, which is this guy over here, and also nice other spores, and quite a few of those microarthropods, which are sitting in the trophic levels. I think this is a nymph stage, or it could just be a leg that got torn off when I was shaking the sample. So really fascinating that we're actually getting the soil food web organisms really in there with the second pile turn. Next slide, please. And I'm sure most of you are familiar with the soil food web. If you're not, so we've got organic matter over here, this first trophic level, and then you have fungi and bacteria who start to break everything down, and then everything eats everything through pooping and looping, right? So the protozoa get in there, and then the nematode. Pooping and looping, looping and pooping all the time. We loop and poop too, right? Not in the same sitting though, hopefully. So Um, and now those arthropods are definitely in there, and then the larger predators ones have come in. So, which is great. We're not quite at the predatory aspect here with the fourth trophic level, but I have seen in some of the other piles that we've done, not particularly related to the Massey experiment, but just with the first batches that we've made, that we do have. These are mites with, got 8 legs. Some of the more predatory mites, which are already sitting into the fourth trophic level, that come towards the end. And then because this is based off the soil food web, obviously they have moles. We don't have moles, we have rats as part of this fifth trophic level, and lots of birds. So, and the birds are kind of loving it. So they're also pooping and looping into the piles. So it will be really fascinating to see, once we get to the nanopore technology, actually what those composite organisms look like, from bacterial, fungi, all the trophic levels as well. And yeah, it's really exciting. So I'm really quite thrilled about this experiment. And it's great to be able to do science and actually push things forward. And great that Massey's actually starting to consider this as sort of something to investigate, to move forward, because that would be revolutionary when it comes to agriculture and horticulture application, especially with this not waste input, to get a really wonderful living output in this compost. So yay, green loop. So that's me.
Thank you for that. That was excellent. Yeah, so it's really fascinating to see what's exactly happening in there. Green Loop is not only set up to support businesses and turn it into compost supporting the farmers, but we are also an educational. We have a big educational site. So Caroline's site is set up as an educational site. So students from Messi, from WIT, from any kind of school can come and visit and see the different systems at work. At the moment, we're using only about 3 or 4 different systems, but we're also gonna test with swales and with in-ground composting. We're gonna add it to the soils and see, what is happening in the plants, what is, little blocks side by side, different inputs, and see the difference in the crops, in the plants above. So lots and lots of things for the future. Green Loop. So we started Green Loop. We started investigated with at the Hibiscus Coast about a year ago. We started with a distillery as a very, very tiny little pilot in June, but really from October is when we actually started with big pickups with 7 businesses. So we've only started in October, which meant that November was actually the first time that we could build our first pile. So we haven't been going very long. So we don't have fully matured compost yet either. So we're very small bit along the way of our journey. But it's very exciting to already see the effects now after such a short time. Not only is it interesting for students and for Messi and for future to see this as a way of taking a waste product on one side and using it to solve a problem at the other side with depleted soils. But the Messi and Caroline also make it possible for us to not only claim that we are creating a nutrient-dense and safe compost to use on the land or in your garden or work with your hands, but with the data and the pictures and that is being collected at the moment, we can now prove that our statement is correct and that we are creating something that is safe to use for humans, it's safe on the soil, and it's safe for animals to graze on that land that has had that applied to. So this is a little impact what we've done so far. So we started in October with 7 businesses. We now, since we've come back from our break, we've now got 10 businesses on board and we're talking with quite a few more. So there's a lot of interest for Green Loop. We've created new jobs with Green Loop as well. So that's been really important for us that we're not only looking after the land, but also our communities. We've won the awards. We now also go to different types of events where food is being, and you can see in the one picture on the side, on the right-hand side. So not only do we now separate landfill, organics, and recyclables, but we also have specific food waste going to Green Loop. So even more diversion really from big events as well and weddings. So from October to the end of last year, we collected 59 bins. And at the moment, we've got about 6 tons of compost cooking and doing its thing. We're picking up almost 1,000 liter of volume-wise a week at the moment, but that's going to increase like really, really quick as well. So yeah, this is Green Loop so far, and we are really keen to be an inspiration or support for other organizations or locations or regions as well. So if anyone has any questions or wants to talk to us about how we got our funding or how we've written our proposals or how we are solving certain problems or where we get our resources from, honestly, feel free to contact us. You are part of the solution. It doesn't matter how small we start, and we're all here to support one another. And that's really our kaupapa as well. So any questions, or you can ask them now, but otherwise feel free to flick us an email, give us a call, go to our website, and we'll get in touch happily.